Greetings, viewer. We are incredibly glad to see you on the channel. Many asked us in the comments, and we did it. May 1945. France has just been liberated from occupation, and its tank forces are in a catastrophic state. Outdated pre-war machines, captured wreckage, and a complete absence of modern technology. The French military understands that a new tank is needed, one that will prove to the whole world that France is once again capable of creating advanced weapons. But very soon, it will become clear that creating the ideal tank is much more difficult than it seemed. This is the story of the French AMX 50 tank. The situation was humiliating for a country that, just 10 years prior, considered itself a leader in world tank building. The only machine after the liberation was the heavy tank ARL-44. This machine had been developed since 1941 under occupation conditions and, even at the moment of its release, looked like a guest from the past. The suspension was copied from the old Char B, one of the pattern of the 30s. In 1945, the French were installing a 15-year-old suspension on a new tank. There was no choice. It was the only system that could be produced in the conditions of a destroyed industry. In March 1945, the French government approached the industry with a proposal to develop a modern tank. The project received the number 141 and was supposed to be the answer to all the humiliations of the war years. The task was formulated extremely ambitiously, to create a tank that would surpass everything that the Allies and potential adversaries had. Among the participants were the companies AMX, Renault, Somua, and other giants of French tank building. The AMX company took on the project with particular enthusiasm. Their engineers understood perfectly well that they did not have time to reinvent the wheel from scratch. The French began to methodically study captured equipment, which, even after the capitulation of Germany, was in abundance. Particular interest was aroused by the medium Panther and the heavy Tiger II. From the Panther, they borrowed the chassis, large diameter road wheels in a chessboard arrangement with 9 per side, and torsion bar suspension. From the Tiger II, they took the concept of heavy armor, but they decided to copy the engines 1-to-1. The German Maybach HL 295 with a power of 1,000 horsepower. The French even turned to the German company Zahnrad Fabrik Friedrichshafen for the transmission, a 5-speed gearbox with a differential turning mechanism. The project received the designation M4. The military formulated requirements that sounded like science fiction. The protection of the Panther, the firepower of the Tiger, the mobility of the T-34, and the reliability of the Sherman. Initially, the tank was planned as a medium one, weighing about 45 tons with a 90mm Schneider gun. But French engineers understood that simple copying was not enough, and then they decided to install an oscillating turret with an automatic loading system, a technology that no one in the world had yet applied on mass-produced tanks. A standard turret consists of one part, where the gun raises and lowers. An oscillating turret consists of 2. The lower part is fixed to the hull. The upper part, with the rigidly fixed gun, tilts up and down. Such a design gave an advantage. It reduced the dimensions of the turret without reducing the internal space. And, most importantly, the gun became stationary relative to the upper part of the turret. In the bustle niche, it was possible to install a simple automatic loader. Shells in 2 drums of 6 rounds each. The mechanism fed them into the stationary breech. No complex systems. Everything was elementary and reliable. The automatic loader promised an incredible rate of fire, An experienced loader could make 6 to 7 shots per minute. The French automatic system theoretically delivered all 12 shells in less than a minute. True, there was a problem. After emptying the drums, they had to be reloaded manually from outside the tank. The magazine was isolated from the crew compartment. In battle, the tank had to withdraw, the crew had to climb out, and load new shells under fire. But the French military considered that the advantages outweighed the disadvantages. Work went slower than desired. Post-war devastation, a shortage of personnel, problems with supplies, everything slowed down the process. Only in 1949 was the hull of the first prototype built. The machine was now called the AMX 50. In the winter, the prototype received a 100mm gun from the Tarbes arsenal. The French decided that 90mm was not enough. Soon, a second prototype was completed with a 100mm gun in a modified turret. And here, an unpleasant surprise awaited the French military. When the prototypes were weighed, it turned out that each weighed 54 tons instead of the planned 45. The tank had gained 10 tons in 4 years. The military constantly demanded to strengthen the armor, install a more powerful gun, and add equipment. The frontal armor reached 110 millimeters, the side armor 100. 54 tons meant that the tank was no longer medium. It was a full-fledged heavy tank, approaching in weight the Soviet IS-3 at 46 tons and the American M-46 Patton at 48. The French planned a fast, maneuverable medium tank, but got a heavyweight. But the scariest thing was not the weight, but the fact that the engine began to choke under the load of the 54-ton machine. That same German HL-295, which was supposed to ensure the tank's superiority in speed over all existing medium tanks, categorically refused to do its job. The French military ordered a fast, maneuverable tank capable of reaching 60 kilometers per hour on the highway. This speed was supposed to give the AMX 50 a decisive advantage in battle. The ability to quickly occupy advantageous positions, flank the enemy, and escape return fire. But reality turned out to be much crueler. During trials, the tank accelerated to 51 kilometers per hour with great difficulty, and that was the absolute maximum. On cross-country terrain, the speed dropped to 20 kilometers per hour. The engine, with a power of 1,000 horsepower, which worked perfectly on 45-ton German tanks, simply suffocated under the load of the 54-ton French machine. Engineers tried to squeeze more power out of the motor, but every attempt at forcing it ended in reliability problems. The engine overheated, parts wore out with monstrous speed, and the resource life fell catastrophically. The French decided to try an alternative. The Sauer company proposed its diesel engine of the same power of 1,000 horsepower. The diesel was theoretically supposed to be more economical and reliable than the gasoline Maybach. They installed the Swiss motor, conducted tests, and received exactly the same result: 51 kilometers per hour maximum. The problem was not in the type of engine. The problem was that the tank was too heavy for any existing power unit with a power of 1,000 horsepower. From 1950 to 1952, the French drove both prototypes around proven grounds, trying to somehow solve the speed problem. They changed the gear ratios in the transmission, modified the cooling system, and experimented with engine settings. Nothing helped. 51 kilometers per hour remained an insurmountable ceiling. For a heavy tank, this was a quite decent speed. The Soviet IS-3 accelerated only to 40 kilometers per hour, the American M-46 Patton to 48. But the French designed the AMX 50 as a medium tank, and by the standards of a medium tank, 51 kilometers per hour was a frank failure. On the other hand, the oscillating turret with the automatic loader worked flawlessly. 2 drums of 6 shells each provided incredible fire rate. The mechanism fed 100mm shells into the breech of the gun with ideal precision and reliability. The French military, for the first time in the history of tank building, received a heavy machine that could fire 12 powerful shells in less than a minute. This was a real achievement. Any enemy tank caught under the fire of the AMX 50 simply did not have time to respond. While it was reloading after the first shot, the French tank was already riddling it from the automatic system. True, reloading the drums remained a problem. After all 12 shells ran out, the crew had to leave the tank and manually load new rounds into the bustle niche of the turret. In combat conditions, this meant that the tank effectively dropped out of the battle for several minutes. But the French believed that 12 shells would be enough to destroy several targets and withdraw to a safe position for reloading. The theory sounded reasonable. There was nowhere to verify the practice. The tank never entered serial production. In 1951, after the completion of preliminary trials, the French military made a fateful decision. Since the tank weighs 54 tons anyway and accelerates only to 51 kilometers per hour, it means there is no sense in pretending that it is a medium tank. Let it be heavy, and since it is heavy, it needs appropriate armament. The military demanded the installation of a 120mm gun on the AMX 50. The decision looked logical. In the early 50s, the main threat to NATO was considered to be the Soviet heavy tanks IS-3 and the new T-10. These machines had powerful armor, which the 100mm gun penetrated with difficulty. The 120mm gun was supposed to guarantee defeat any Soviet armor at distances up to 2 kilometers. The French took the American T-53 tank gun as a basis and seriously reworked it for their needs. The result was a powerful modern gun with excellent ballistics. But then a new problem came to light. They weighed significantly more than the 100mm rounds. The automatic loader, which worked impeccably with 100mm rounds, began to malfunction when working with 120mm ones. The mechanism was not designed for the increased weight and dimensions of the ammunition. The feeding of shells became less reliable. The time between shots increased. Failures began. French engineers faced a classic problem. Every improvement in one area created new problems in another. On July 14, 1951, an unusual military parade took place in Paris. The French government decided to demonstrate all the new military equipment that was in service or undergoing tests. Along the Champs-Élysées passed EBR armored cars, ARL-44 tanks, which by that moment had been reclassified as tank destroyers. The culmination of the parade was 2 AMX-50 tanks and the Foch tank destroyer, built on the same chassis. The public enthusiastically welcomed the new technology. Journalists wrote about the rebirth of French tank building. The military proudly demonstrated the oscillating turrets and spoke about the revolutionary automatic loaders. But very few knew that these shiny machines would never go into mass production. While the AMX-50 prototypes were rolling along the Champs-Élysées, new improved versions were already being designed with might and main in the design bureaus. The military hoped that the next iteration would finally solve all the problems with the engine and weight. These hopes turned out to be in vain, but the French would learn about this later. On June 25, 1950, the Korean War began. North Korean troops, supported by Soviet T-34-85 tanks, crossed the 38th parallel and began a rapid offensive to the south. American and South Korean units turned out to be unprepared for such a strike. The war showed that the USA urgently needed new tanks, and needed them immediately and in huge quantities. The American military industry reacted instantly. The development of a fundamentally new tank would take years, and the troops needed to be rearmed right now. A solution was found quickly. Take the M46 Patton hull and put the turret from the experimental T-42 on it. The resulting hybrid was named the M47. The design was a compromise, but it could be instantly launched into mass production. In December of the same year, the American Army signed a contract for the production of the first 500 machines. Production unfolded at the Detroit Tank Arsenal and American locomotive plants. By the summer of 1952, the first serial tanks began to arrive in the troops. From 1951 to 1954, the Americans produced about 9,000 units. But this was not enough. Almost immediately after the start of serial production, the U.S. military command made a strategic decision on mass deliveries to NATO allies. The logic was ironclad. The Cold War was gaining momentum, the threat from the Soviet Union seemed real, and European allies after the World War had frankly weak tank forces. The Western Bloc needed to be strengthened urgently. And here happened what the French could not have foreseen, even in their darkest nightmares. While the Americans were stamping out thousands of machines, they were already developing the next generation. On November 1st, 1950, even before the official adoption of the previous model into service, the USA had already launched the M48 program. The new tank was designed with a fully cast hull and an ellipsoid-shaped turret. Its production began in 1952 and continued until 1959, producing 12,000 machines. For the American Army, the new model was a priority. All the most modern samples went to American units. But what to do with the thousands of the previous generation, which for the Americans themselves were already considered outdated? These tanks were too new to be written off as scrap metal, but not good enough for their own army. The solution turned out to be simple and, for the French, catastrophic. Transfer all surpluses to European allies completely free of charge. France received 856 combat-ready machines without paying a single franc. Almost 900 modern tanks with 90mm guns with reliable motors and a proven design. For comparison, the French over the same years were able to build only 2 prototypes. The Americans during this period produced 9,000 units and distributed a significant part to allies simply like that, under the military aid program. For the project, this was a fatal blow. The entire point of creating the French machine was to rearm the army with its own developments. National pride demanded proof that France was capable of creating world-class technology, despite the post-war devastation. The French military dreamed of a tank that would not yield to American and Soviet analogs, and at the same time would be completely French. And now the Army received almost 900 excellent American samples that could be operated immediately, without modifications and tests. Why wait years while engineers solve the problem with the motor and weight, if tomorrow you can arm divisions with ready-made machines? Why spend millions on development and production if allies give theirs for free? The questions were rhetorical, and the answers obvious. The French project as a medium tank instantly lost all meaning. The military found themselves faced with a choice. Either close the program and admit that 5 years of work were wasted, or look for a new role. The AMX company and the military leadership chose the second option. Since the machine is not needed as a medium tank, it means it is necessary to turn it into a heavy destroyer of Soviet armored monsters. It was an attempt to save the project by changing its class and purpose. But, as it would turn out very soon, the French development was even less suitable for the new role than for the old one. From 1954 to 1955, French engineers created a new version, named Surblindé, which translates as up-armored. Inspired by the Soviet IS-3, they completely redesigned the nose part of the hull. Instead of a regular sloped frontal plate, they installed a pike nose, two armor plates meeting at an angle, like on Soviet heavy tanks. This shape theoretically should have significantly increased protection against shells. The thickness of the armor was brought up to 200 millimeters along the line of sight. The turret was made lower to reduce the overall height and create a smaller target. Everything looked promising on the blueprints, but when the prototype was built and weighed, it turned out that the machine weighed 64 tons. Over several years of design, the tank had become heavier by another 10 tons. Tests of the Surblindé version turned into a nightmare. The suspension, which was designed for a much lighter machine, cracked under the load of the 64-ton monster. Road wheels were destroyed with frightening speed. Torsion bars could not withstand it. The engine strained, trying to move this hulk from a standstill. Even after strengthening the suspension, problems with mechanical reliability remained critical. The French military looked at the results in order to forget about the Surblindé. Strengthening the armor turned out to be a dead end. The tank had become too heavy for its own chassis. It was necessary to look for another solution. From 1955, the French involved German specialists in the project. A whole team of 70 engineers arrived from Germany, led by Professor Karl Maybach, the son of the founder of the famous Maybach Company. The group received the name Group M in honor of its leader. The task was simple: finally force this cursed engine to deliver the necessary power and accelerate the tank to an acceptable speed. Professor Maybach personally led the mission. 70 German engineers worked side by side with French colleagues in the workshops of the AMX company. They studied every detail of the motor, changed settings, and tried to squeeze out the promised power. The goal seemed achievable: to accelerate the tank to 65 kilometers per hour on the highway. For this, it was required to raise the power to 1,200 horsepower. The Germans were confident that they could solve the problem. After all, it was their own motor, albeit in a modified version, but even the German specialists suffered a fiasco. No matter how they struggled, they could not manage to squeeze more than 1,000 horsepower out of the engine in a reliable way. Every attempt at forcing led to a catastrophic reduction in resource life. The motor overheated, destroyed itself, and required constant repair. Group M toiled for months, but there was no result. For the German engineers, this was a humiliating failure with their own engine, which they could not force to work properly. In parallel, from 1956 to 1958, the French created the final version, named Surbaissé, lowered. They learned lessons from the failure of the heavy model and went in the opposite direction. They designed a new cast hull of lower height and installed a lighter turret of the fourth type, Tourelle D, which paradoxically turned out to be taller than the previous one, but lighter. They managed to reduce the weight to 58 tons. In 1958, the final prototype went out for testing. The military hoped that after so many years of refinements, the machine would finally show the promised characteristics. They expected that the tank would accelerate to 55 kilometers per hour on the highway and to 45 on dirt roads. Reality turned out to be cruel. The machine barely reached the same 51 kilometers per hour as the very first prototypes 9 years ago. Over 9 years of work for millions of francs spent for the participation of 70 German engineers, the speed did not increase by a single kilometer. By the end of the 50s, the oscillating turret, which once seemed like a brilliant solution, began to lose popularity in the world. The reason was simple. The gap between the upper and lower parts could not be reliably sealed. In an era when everyone was seriously preparing for nuclear war, a tank that could not protect the crew from radioactive contamination and toxic agents became an anachronism. The Americans, the British, and Soviet designers abandoned oscillating turrets for precisely this reason. In addition, new types of ammunition appeared, shaped charge shells, which penetrated any reasonable thickness of steel armor. The concept of a heavy tank with massive armor was rapidly becoming outdated. Why drag 60 tons of steel if an anti-tank missile will punch through it like cardboard? Mobility was becoming more important than protection, and the French machine had neither acceptable armor nor normal speed. On June 1, 1958, the National Assembly of France approved the new composition of the government. The post of Prime Minister was taken by General Charles de Gaulle, the man who, 12 years ago, headed the provisional government of the liberated country. The country was in a deep political crisis caused by the war in Algeria. De Gaulle returned to power with one goal: to restore order and stop the bloodshed. One of his first tasks became the revision of military programs. De Gaulle was a pragmatist and did not tolerate the empty waste of money. He looked at developments not with the eyes of an engineer, delighted by technical solutions, but with the eyes of a politician, understanding the price of every franc. The new administration began a methodical purge of projects that had no chance of completion. The list was long. Dozens of programs were draining billions from the budget without giving a result. De Gaulle and the Minister of Defense requested all documents regarding the project. When they studied the folders, the picture that emerged was depressing. The program began in March 1945, immediately after the liberation of Paris. 13.5 years had passed. They built 5 prototypes, spent millions of francs. The result? 0 tanks in service with the Army. Not a single machine ever made it out of the testing stage. Don't forget to like if the story was interesting. Write in the comments what technology you want us to tell you about next, and subscribe to the channel so you don't miss new stories about the most absurd military technology in history.